here. All right, so yes, I am recording this. All right, so we have, it's going to be our 2-column proof checklist. Yesterday when we were actually doing this, Friday when we were doing this, we were actually doing the types of ways that triangles can be congruent. So we came up with this on page 67. We have the different types right here, and so we're going to use this in our 2-column proof for today. So I'm going to ask you to go back and forth for this. All right, on this 2-column proof checklist, so what we're going to do is we're going to go through and identify things before we can actually even, get into any of the math or geometry for this. So when I look at something, I'm going to start with parallel lines. So if I have something that has parallel lines, that means I'm going to have alternate interior angles. We did alternate interior angles in Unit 1. Okay, so now we just need to identify where they're at. So when we have parallel lines, we have congruent angles. An X in the picture. If it forms an X, I have vertical angles. So I know I have two angles that are going to be congruent, but from that, I'm going to have to figure out which ones are congruent, and my reason will be that they are vertical angles. Okay, all right, next thing we're going to have is shared side. If they're both have the same side, so if they're right next to each other and they're sharing the side, that means that that side's going to be reflexive. It's going to be in both of the triangles. So it's going to be congruent to itself. So this one's going to be, and I'm going to use reflexive for that one. Okay, midpoints and bisector. We were working with midpoints on Friday. Okay, midpoint. So if I have the midpoint, I know that, what do I know? It's equal, right? So remember we're talking about that sandwich on Friday? If I cut something at the midpoint, what do I know? Both sides are congruent. They are equal. Very good. So it means the exact same thing as bisector. Bisect is actually a line that cuts into two equal parts. Midpoint is just a point which actually tells me where the middle is. So both these things go together. But this is just a point and this one's a line. So whenever I have those, it cuts into two equal pieces. So I just need to know which one I'm going to use. So it's going to be the definition of either midpoint or definition of bisector. Okay, perpendicular lines. When I have perpendicular lines, it's going to make 90-degree angles. So that's going to help me out. So all 90-degree angles are going to be congruent to each other. So this is important for that. And a perpendicular bisector. This is a special one right here because it is perpendicular and it is bisecting. So it is two things together. So if I'm actually looking at it, so I'll give you an example of a perpendicular bisector here for your notes. So if I have this, so I have a line. I'm going to draw a perpendicular bisector. So from this point, if it is bisecting, that means that this one here is congruent to this one here. So that's going to be the bisect part. If it's perpendicular, they are 90 degrees on both sides there. And from here to here, they share this side right here. If both triangles have the same portion in them, they share the same side, that means it's going to be congruent to itself. So this is going to be reflexive, so it's going to be congruent to itself like this. So just given this much information, I know I have the side, an angle, and a side. This one's also a side, an angle, and a side. So both triangles will be congruent to each other by side, angle, side. And if I'm looking at my notes from Friday, so right here, side, angle, side, it is one of my ways to prove that the triangles are congruent. So they are going to be congruent to each other just by that given information of perpendicular bisector. So that's actually important. So we're going to use this checklist. Now this checklist is going to end up in your handy dandy notebook. So hopefully you guys still have that. It's going to be in the back page. We're going to add some more stuff to that. So you're going to have the 2-column proof checklist in there. All right, so we're going to take a look at this page now. Slide down a little bit. There we go. There we go. Okay, so it says that RS is the perpendicular bisector of PQ. So class, what is the first thing I should always start off in a 2-column proof? Given. So I have a long given here, so I'm going to abbreviate perpendicular. Now, there's one thing I want to show you which I did not do yet. Okay, perpendicular lines. There's a symbol for perpendicular. It's an upside down T. Upside down T is the symbol for perpendicular. Just like parallel lines has a symbol which is like that. That's the symbol for parallel lines. So I'm gonna shorten this up right here. So for 1, it says RS is perpendicular bisector of PQ. What is my reason for this? It's given, right? I have given there. Okay, so now, just given that information, I know it's perpendicular bisector. So now, because it's perpendicular, what do I know? Okay, I have congruent parts, but what about this perpendicular piece right here? What is a perpendicular piece going to tell me? It's almost like it's on this piece of paper here. Makes 90-degree angles, right?
Yeah.
So, where are my 90-degree angles at? It's going to be at S, but then I have multiple angles here. So I have to use 3 points to be able to label it. RSQ, okay, and RSP. So I'm going to say that angle RSQ and angle RSP is 90 degrees. And the reason for that is from this given, so we got from this piece right here, right?
Yeah.
From perpendicular, so it's going to be definition. Definition of perpendicular. Yes. Yes, you may. All right. So let's take a look at what we got over here. So now the next one. Let's take a look at this bisecting piece. So it's still part of the given. So because of the bisector part, what do we know? Okay, which now can you tell me those sides? PS and QS, right? I'm gonna do the same way. So PS and QS are going to be congruent. So PS is congruent to QS, and that's going to be definition of what?
Congruent.
No, not congruent. Why do we get that information?
Is it bisector?
Yes, it is. It is bisector. Definition of bisector. Okay, so now let's go ahead and mark that. So I'm marking it here, marking it here. What other information do I have?
Yeah.
Let's look at the checklist. What other information do we have? Do we have parallel?
No.
No? I have shared side. Thank you. I have shared side, don't I? Which one's shared side? RS, right? So they both triangles have RS in it. So for step 4, I could say that RS is congruent to RS And my reasoning is,
Sure.
nope. What was the reasoning?
Oh,
Reflexive. That's the reasoning for this one right here. That's why I underlined that one.
is it definition?
That one's just reflexive property. So I have reflexive property there. All right, so let's take a look. So now I have this much information here. So we know that if both these are 90 degrees, are they congruent?
Yes.
Yeah, they're congruent to each other because they're both 90 degrees. So I'm going to state that one also. So I know that one because definition of, perpendicular. So they are going to be congruent. So it's going to be 5. So it says angle RSP is going to be congruent to angle RSQ. And that goes along with the definition perpendicular also. Because we know that perpendicular lines give me 90-degree angles, and all 90 degrees angles are congruent. Now, 6. So 6 right here. Now, do we have enough information to say that this triangle right here is congruent to this triangle? How much information? What would I call it? I heard it. Side, angle, side. Very good. So it's side, angle, side. So both these triangles have side, angle, side. So I'm going to say that this triangle, RSP, is going to be congruent to triangle RSQ. And my reasoning is going to be side, angle, side. Now, here's going to be a new vocabulary for this one. So, new vocabulary. So, now that I proved that the triangles are congruent, if the triangles are congruent, that means all pieces that are corresponding to each other are congruent. So, if I know that triangle is congruent to that triangle, angle P is congruent to angle Q, right? Because they are going to be congruent, that means all parts are congruent to each other. So I can go through and say PR. So step 7, PR is going to be congruent to QR, just like we have here. And my step right here, my reason for this is going to be new. It's corresponding parts of congruent triangles are congruent.
I thought it would be PS to SQ.
PR, QR. So PR and QR, these up here.
What does that mean again? The 7?
Corresponding parts of congruent triangles are congruent. Now, you guys have out your handy dandy notebook already?
Yeah.
Okay, so let's take a look at your handy dandy notebook to make sure that this is. So, right here in our handy dandy notebook, we have it down here at the bottom. You already have it in your handy dandy notebook, but now it's time to talk about it. So, corresponding parts of congruent triangles are congruent. Now, and for the abbreviation for that one, we say CPCTC. Now, this could only be used after we prove the triangles are congruent. So when the triangles right here, so there's actually a 2-column proof right here. It already proves that the triangles are congruent. But after the triangles are proven to be congruent, what's going on?
Oh no, turn this in.
Is that what you're supposed to be doing right now?
Is this a photo?
It's not what you're supposed to be doing right now. So, right here, triangles are congruent. And then after you prove the triangles are congruent, everything after that, you could actually say corresponding parts congruent triangles are congruent. So all pieces are congruent after that.
So like that's going to be a proven?
Huh?
Like that's only going to be a proven?
After you prove the triangles are congruent. So you're going to have like a side angle side, side side side, something like that. And then after that, you could prove that all parts are congruent to each other.
So it's always going to be after that?
Only after triangles are proven to be congruent. Okay? That's the only time you could use it. All right, you guys have that in? All right, let's take a look. Okay, so now let's take a look at the next problem here. So if I'm going by my checklist, so 1, my first statement is going to be given. So A, B, what do those lines right there mean? Parallel, thank you. Parallel to ED. And C is the midpoint of AE. So we have two different things being stated in that first given right there. So we have two things. So we're going to talk about it at different times. So now, if I'm looking at my checklist, I know that AB and ED are parallel, so that's going to be one of my first things I'm dealing with, right? I know I'm going to have alternate interior angles. So where am I going to have alternate interior angles at? Let's take a look. So I'm going to show you here. So those are my parallel lines right there. So when we have alternate interior angles, we have to deal with a transversal. That means the line that cuts through it. So if AE is my transversal, AE is my transversal right here. So it's cutting through both of these. That means that angle A is going to be congruent to which one?
E.
E, very good. Angle A is going to be congruent to angle E. These are alternate interior angles. So this is actually given because of parallel lines. So 2, I could say that angle A is congruent to angle E. My reason is alternate interior angles. Alternate interior angles. Now, is there anything else because of that? What do we got? I heard it? So you're saying B, all right, is going to be congruent to D. For what reason? Alternate interior angles again, right? Because they're off the parallel lines, and BD is cutting through those parallel lines. So those are my alternate interior angles. Angle B congruent to angle D. Yes, you may.
The same rule.
Yes, alternate interior angles again. Okay. Is there anything else we have here?
C.
I have what?
C.
C. I have C. What about C? Oh, okay, but is there a special thing here?
Vertical angle.
Vertical angles, thank you. That's what I'm looking for.
Oh,
So
this
if
makes
I'm
an
looking
A.
at the picture, do they make an X?
Yes.
I'm going to have vertical angles. But now, where are the vertical angles going to be? I can't just say C. Because if you look, there's 1, 2, 3, 4.
Wouldn't it be angle? No, wouldn't it be ACE and BC?
AC what?
E.
ACE is a straight line.
Oh, ACB and then
Very good,
BC.
very good. So for 4, angle ACB is going to be congruent to angle.
DCE.
Now, let's take a look. Let's make sure it matches. ACB. This one has 1, right? One marking. So therefore it has to be E, C, D. Very good. E, C, D. And that's going to be my vertical angles. Now, 1, 2, 3. Now, I'm not done with this, but if you notice, I have all three angles now, right?
Yeah.
Okay, so let's go back and look. So that would be, okay, raw. That'd be angle, angle, angle. So is that enough to prove that the triangles are congruent? No, I can't prove the triangles are congruent. So we need more information. So I'm going to go back. So we need more information from that one. Okay. You remember this part of the mid of my given right here? C is the midpoint of AE. C is the midpoint of AE. So what does that tell me?
That both sides
they're
are
equal.
congruent.
What sides are congruent? Yes. They are congruent, they are equal, but what are they going to be called? What do I call them? AC
and
and EC are going to be congruent, right? Because it's the midpoint of AE. AE is my whole thing. So AC is going to be congruent to EC. What is my reason for that one?
Definition of midpoint.
Very good. Definition midpoint. Okay, number 6. So let's go ahead and mark this right here. Now that I mark that, do I have enough information now to say that the triangles are congruent?
Yeah.
How?
Because all the marks are the same.
Okay, but I go back a page. I have angle, side angle, don't I?
Yep.
Angle, side angle, don't I?
See?
Yeah, so I could say that they're angle, side angle, or I could also say angle, angle, side, but let's just do angle, side angle to make it simple, right? Angle, side angle. So triangle ABC is going to be congruent to triangle what?
EDC.
EDC, because it goes 1, 2, 3, right? And then EDC is also 1, 2, 3. EDC. Very good. So 6 by angle, side, angle. Okay, so I have angle, side, angle there now. But did I prove what it said to prove? Say no. No, it did not prove it yet, right? So after these two triangles are congruent, that means all pieces are congruent. All pieces are going to be congruent. So that means that I could say that AB is going to be congruent to ED. So step 7. So AB is congruent to ED. What is my reason?
Isn't it corresponding parts of congruent triangles?
There we go. Corresponding parts congruent, triangles are congruent. So we prove that triangles are congruent, and then after that we can prove that they are congruent also because all parts are congruent. Does that make sense?
Yeah.
Okay, so let's go ahead and this one goes here. Raw. So that one's there. This one goes on top. So this one goes on top of that one. So you could always see the checklist first. And then we're going to take a look at page 68 here momentarily. Okay, now let's take a look at 68. Now on 68 is what you guys are going to work on here momentarily. So, raw. There we go. So on page 68, we actually have the practice over here. Now, what you're going to do is on this one, you must label the picture as you work. So you guys are going to do the 2 column proofs for this. So we're proving that triangles are congruent. So we're trying to prove that this triangle ABC, so this triangle right here, is going to be congruent to this triangle right here. There we go. So we have extra pieces in this. So it's not always going to be just 2 triangles. We might have extra pieces like this one has. So this one, we're only proving this one and this one are going to be congruent to each other. So, okay. Now, you have to use your information and use the stuff that we learned already. Now, any questions? No? All right. Don't forget, like and subscribe.
Thank you,
I already did that.
You already did that?